Alright friends, let's look at our last set of notes for Unit 11. This is notes 11.6. Okay, we're just still talking about exponential functions, but we're talking about what it might look like in the real world, because when you take your STAR test, guess what? They're going to ask you some real world questions. So we need to kind of go over what that might look like. So I do want you to try your warm up on your own. Number 1 and number 2, remember I should see a copy of these notes with what I've written down and with the ones I've asked you to do yourself inside of your algebra folder. Okay, so try those two the best you can. If for some reason you have got those really confused and you think, Ms. Bailey, I really need help, please send me an email. I genuinely love hearing from you and would love to help you. Okay, let's take a look though at a real world example here. So it says, visitors to a popular gaming channel are invited to subscribe to a newsletter. The number of subscriber T weeks, so that's important, so I'm going to highlight that, T weeks, after launching the newsletter can be modeled by the function ST27 times 1.035 to T. Okay, now notice this is the same formula we've been talking about all week, that f of x is equal to a, b, x, where a is your y value or your initial value, right? And what does initial mean? When I say initial value, what does that make you think? The first value, right? The first value where you start, okay? And your b is your growth or decay, put a little slash there, or decay, okay? And if you'll remember, okay, and it's okay if you're still a little fuzzy on it, but remember, growth, right over here to the side, has to be greater than 1. Sorry, b has to be greater than 1. Let me fix that. B has to be greater than 1 to show growth. Okay? To show decay, B has to be greater than 0, but less than 1. Okay? And remember, growth is going to kind of go up like this. Decay is going to go down like this. So now that we've kind of got some of the basics out of the way that we've already talked about this week, let's take a look at this function. Well, already I know that this time instead of f of x, they're using s of t, but it means the same thing. My a value right here, my initial value, is that 27. My b value is this 1.035, and because it's greater than 1, I know that this has to be growth. Okay? And t, that is the amount of time that has passed, which we haven't plugged that in yet. We're going to kind of look at what that would look like today. So it says, how many subscribers are there when the newsletter first launched? So remember, when it first launched, what was our initial number? What would A be? 27. So initially, I had 27 subscribers, right? And you could put that, you could put 27 subscribers. Or 27S, I would accept either one. Is the subscribers from week to week getting bigger or getting smaller? Well, remember, we already talked about if it's greater than 1, then it's growth, right? And growth would be getting bigger. Exactly. So, how much bigger is it getting? Well, what did it say? What was our B value? 1.035 times bigger. All right, so let's look here. This next one's where it gets a little bit different than what we've talked about before. It says, how many subscribers are there expected to be after 1 year or 52 weeks? What about 2 years? Well, let's look at this formula here. ST, what did it say that T stood for? It stood for weeks. Well, it told me there's how many weeks in a year? 52. So I'm looking for the answer after 52 weeks. How many subscribers after 52 weeks? So the formula is still the same. It's still 27, that initial number. And then it's getting bigger by 1.035. And T, we already said, was 52 weeks. Okay. Now, you might be thinking to yourself, Miss Bailey, I don't know how to do 27 times 1.035 to the power of 52, but that's okay, because what can you use? I can use my best friend, Desmos, and I can plug it in how I see it. I can say 27 times 1.035, and then now this is the little keyboard function at the bottom, okay? My iPad automatically pulls it up, but if you're like, Miss Bailey, I don't see any of these options, it's that little keyboard at the bottom. And then I'm going to put A to the power of B, because then it lets me put in the number I want, which 52 weeks. 161.533258316, or if we round to the nearest whole number, that would be about 162 subscribers. Okay. Then it says 2 years, but can I go from weeks to years? I can't, but if there's 52 weeks in 1 year, how many weeks would be in 2 years? 104. So use the same formula. Now I'm looking at 104 subscribers, and you're still, not subscribers, weeks, sorry. You're still using that initial number, 27. It's still growing by 1.035. And this time it's for 104 weeks. And once again, I can use my best friend Desmos, and I can even just replace that really quick, 104, and that 966.407168227 would round to about 966 subs or subscribers. Okay, look at number 4. Number 4, I'm actually going to have you try on your own. It says, describe how the number of new subscribers differs between the first year, second year, and the third year. Why do you think this happens? So I want to see what your opinion is. I want to see what you think. But think about it like this. Exponential growth is where it grows really, really, really big for a long time, right? It goes up and up and up at a crazy rate, as opposed to just steadily going up for a little bit, right? Think about that when you're kind of trying this one on your own. But I want to see in your own words what you think is going on there. All right, let's look at the back of this page. It says what this looks like on STAR. You are actually going to try both of these on your own. You're going to try example 1 and you're going to try example 2, but I'm going to read both of them. So this first one says the mosquito population after X months can be modeled by the function g of x 15 times 1.3 to the x. Complete the statement for each of the values. Remember, you're still looking at this formula right here. Still the same. If your b is greater than 1, would this be increased growth or decreased decay? What is the rate each month? Well, think about how far past that 1 the beginning mosquito population was. What was the initial number? Okay, try that one on your own. Circle the correct answer or underline or highlight the correct answer on that one. Example 2. A bank account earns annual compound interest. No additional deposits or withdrawals were made after the initial deposit. The balance in the account after X years can be modeled by the function, and again, it's still this same formula, same rule. Which statement is the best representation of the values in the function? Well, notice this has to be growth, right? This is my initial. X is the amount of time. So look at each of these and pick the 2 that make the most sense. All right. I will see y'all next week.